This is this is the Math 1113 Zoom meeting for this week, May 5th to May 9th, and we're hitting section 7.2 for the rest of the week. Getting off of identities and on to trig formulas. We are going to bury you in trig formulas. My pen is dying a little bit. The first set of them are called addition and subtraction formulas. Page 581, addition and subtraction formulas. There are 6 of them. Zoom in on them. There are 2 for the sine, 2 for the cosine, and 2 for the tangent. They prove the one for cosine. If you can follow it, they give it to you here. I don't think I'm going to try online. It works off this diagram. I do it in class. I got a lot more space. I don't know if it still helps anybody. So you might have to take this on faith. What I might do is just use the calculator. And so what happens is the sine formulas, they don't really number these, but I'll write the first one down. They use an s plus t for some reason. And it works out the sine of s cosine of t plus cosine of s times sine of t. And I may just punch numbers in one just to prove it really works, and maybe that'll help you believe the others. You can do this in radian mode, degree mode for any numbers for s and t. Let's say, how about s? I'll just use 3 and t is 4. So really you have a sine of 7 there. 3 plus 4 is equal to a sine of 3, a cosine of 4, plus a cosine of 3 sine of 4. I'll punch both sides. You can punch the first one as sine of 7, or like I say, you do this in radian mode. It would work if these were 3 and 4 degrees or 3 and 4 radians. Sine. All right, 3 plus 4. 0.656986. Let's punch the other side. It goes sine of the first, cosine of the second, plus cosine of the first, 3 cosine of the first, and sine of second. Drum roll. Yeah, you get the same thing, 0.65986. Somebody through 400 years of math history, someone has figured out these formulas, and it's a way to expand these formulas. I'm just going to make a few comments about them. Do not get wedded to the actual letters. Think of this as like first and second. So no matter what they call them, so then you go sine of the first, cosine second, cosine first, sine second. So just take them as first and second. That way, if they use A's and B's, X's and Y's, Y's and Z's, you won't get confused if they switch the letters. You cannot get wedded to the specific letters. All right, let me just make some comments about them. I'll rewrite them again. A sine of an s plus t, a first plus a second. In fact, I'm just going to write a first plus a second is equal to the sine first, cosine second, cosine first, sine second. And notice the sign here and here match. They're the same. So then when you do a sine of a first minus second, it's the same pattern. Sine first, cosine second, minus cosine first, sine second, and this, again, are the same. All right. Formulas for cosine. And let me pause for a second. Okay, formulas for cosine. Cosine, again, I'm going to write it first plus second. Whatever they call the first thing, whatever they call the second thing. That goes cosine of both. Second, and uses the opposite sign, and then sine of both. This and this are opposite. And so if you have a cosine of first minus second, then that would go cosine of both plus sine of both. And again, opposite. And from these, I could prove the third, but I guess I won't. If you go a tangent of a first plus a second, then turns out that you do, almost like you distribute them, plus tangent second. But on the bottom, one minus, and it turns out the product. Tangent second. And if you go tangent of a first minus second, again, the top, like it distributes, first minus tangent second. But on the bottom, you go one plus the product. Tangent second. So top signs here are the same. Again, you don't have to memorize this online. You would in class. I guess it's an advantage of going online. You got no way to make you memorize it online. Same, same, and then on the bottom, they're opposite. I get this all confusing. Opposite. Here to here, and then the same here to here, and then opposite on the bottom. Okay, there are other groups of formulas, but before we're going to bury you in the next section. Let's, excuse me. Let's get some examples of these. This is pretty much all. There are some others, but I guess we're not going to mess with them. Start on page 587, say with number 3. So they want you to evaluate sine of 75 degrees. And this is not a circle value, but you can use these formulas to find an exact value. You can use these formulas to find exact value. You must bust up 75 degrees into two pieces. There can be more than one way to do that. There can be multiple ways to do that. All right, but I'll pick an obvious way. Sine of 75 degrees can be written as a sine of 30 degrees plus 45 degrees. You want to pick pieces on the circle. This is why we did those standard values. When I do this, this is like your S and this is like your T, or this is like your first and this is like your second. So from the formulas we just did, it goes sine, cosine plus cosine, sine. Sine 30 degrees, cosine 45 degrees, plus cosine 30 degrees, sine 45 degrees. See, this is your S, this is your T, it's cosine T, same sign in the middle, and cosine S, sine T, or sine first, cosine second, plus cosine first, sine second. So you can't, when we put numbers in or whatever they call them, it busts up, it expands like this. And hopefully you remember off this circle, your sine of 30 degrees is a half. If you have it memorized just as well as I do. Your cosine 45 is root 2 over 2. Plus your cosine of 30 is root 3 over 2. And your sine of 45 is root 2 over 2. This is this, this is this, and this is this. Well, this is going to give you root 2 times 1 is root 2 over 4. Plus, and then you'll have root 6 also over 4. You can put this together as root 2, add root 6 over 4. And I hope you know, don't get root 8. This is not square root of 8. These are unlike pieces, you can't simplify them. All right, just to give you some confidence in this, use calculator to check. So I'll punch sine of 30 degrees at 45 degrees. And you do need to be in degree mode. This would not work in radians to come out this. Sine of 30 is not a half. Sine of 30 radians is not a half. I have no idea what it is, but it's not going to be a half. Okay, so we're going to punch sine 30. I didn't check degree mode. Am I in degree mode? I am not. So down, over, enter, degree mode, quit. Okay, so sine of 30, add 45, and you could have punched sine of 75 there as well. Enter. You're at 0.9659. Now, this side can be punched in either degree or radian mode. That won't matter. This is just numbers. So it would work in either degree or radian mode. I'll punch it parentheses, square root of 2. Add square root of 6. Close and divide by 4. Do we have a drum roll? Same thing. So I hope that proved 6 over 4, also got 0.9659. I hope that proves something to somebody, not just to me. You can also check with the back of the book as well. Okay. Okay, how about a tougher one, maybe like 19 pi over 12? Number 9. Finding viruses, maybe it'll go away. Number 9, page 3. How do I get that to go away? Just hit it. It'll go away. Yes. No, come on. Gum. Okay, page 587, number 9. Well, it's got a sign again. How about 13? I'm sorry, let's do 13. That would be a cosine over 12. Okay, now remember, 30 degrees, all right, that's pi over 6. 45 degrees is pi over 4. 60 degrees, that's pi over 3. So why don't we convert them to being over 12 and see if I can puzzle out how to bust this up, because it isn't quite obvious. I don't have everything memorized. This would be 2 pi over 12. This would be 3 pi over 12. 4 times 3 is 12, 3 times pi is 3 pi, 2 is 6 and 2. And then this would be 4 pi over 12. So I want to hit 11 pi over 12. Well, you could go further around. 9 pi over 12. 3 pi over 4 is going to be 9 pi over 12. And then you could add 2 pi over 12 and get to 11 pi over 12. Now, like I said, there's multiple ways to do it. So I'm just trying to find the first way that comes to me. So yeah, I could bust this up as a cosine of 9 pi over 12, add 2 pi over 12. Now this is 3 pi over 4, and this is pi over 6. And the cosine formula, remember, went cosine, cosine, opposite sign in the middle, sine, sine. So this goes cosine over 4, cosine pi over 6, minus, see this is opposite, and sine of both, sine 3 pi over 4, sine pi over 6. All right, so then I hope that you know that cosine of 3 pi over 4 is in the second quadrant. That'd be a negative root 2 over 2. Cosine pi over 6 is in the first quadrant, that's your root 3 over 2. Minus sine of 3 pi over 4 is positive root 2 over 2. And your sine of pi over 6 a half. So you're going to wind up with a negative square root of 6 and minus the square root of 2. And it's all over 4. So I'm getting that a cosine of 11 pi over 12 should be equal to a negative square root of 6 all over 4. Here's one way to remember 11 pi over 12, we're just short of 12 pi over 12, we're just short of pi. Cosine of pi is into the second quadrant, it should be negative, and this side is saying it's negative. All right, going to need to be radian mode. Let's punch, switch back to radian mode. Radian. Cosine of 11 pi divided by 12. See, that's the x leg at 11 pi over 12, 0.9659, negative 0.9659. All right, a parentheses negative square root of 6 minus a square root of 2, close and divide by 4. And there you are. So you found an exact value for it using these trig formulas. All right, in the next section, they're making you use the formula backwards. Okay, for problems 15 to 19, still page 587, 15 to 19, they're using the formulas backwards. So if you go to like 15, and you're going to sine 18 degrees, cosine 27 degrees, add cosine 18 degrees, sine 27 degrees. You see, this is like your first, this is like your second. So this is cosine first and sine second. See, that pattern matches with a plus sign there, match sine, cosine matches a sine for us. So this is equal to a sine of first plus second, which is equal to a sine of 18 degrees, add 27 degrees, which I think you'll find is a sine of 45 degrees, which is square root of 2 divided by 2. And once again, you can check it. Back to degree mode. So sine 18, cosine 27, add cosine 18, closer, sine 27, and then when you do second square root of 2 divide by 2, and you get the same thing. Okay, so it's a matter of matching the right side, say, back to the original. Okay, then they're going to give you more identities. 15. Down to okay, just to put in the assignments, we're going through 3 to 57 odd here. So what they have next is identities, and I think you'll find these identities, if the first ones drove you a little nuts because it was hard to do. Basically, it's a matter of verifying these identities using the formulas. These identities match the formulas. When you go from 21 through 40, really through 45 identities, they match the formulas, which tells you what to do. The formulas, let the formulas tell you what to do. So for example, 21 says prove or verify that a tangent of pi over 2. Oh yeah, and I remember this one. This one isn't going to work. So I bet we'll show you why. I'm reaching back to the formulas, and you see how it matches a tangent of s minus t. You know, tangent first minus tangent second over 1 plus the product of them. All right, so directly matches, and most of the time, directly matching will work. So we'll try it that way, and I'll show you what happens. That means you're going to go tangent pi over 2 minus tangent u over 1 plus tangent pi over 2 times tangent u. All right, but I don't know if you figured out, you got a bit of a problem. Tangent pi over 2 is infinity. If you think around to the circle at pi over 2, coordinates are 0, 1, tangent is your y over your x, which is 1 over 0, which is undefined. So that's what happens when you try a direct match on this one. But most of the rest of them, a direct match will work fine. Unfortunately, you run into this problem with a direct match on this one. I'll just show you punching in the calculator. A tangent, make sure we're in radian mode. It doesn't really matter. Actually, it might matter. It will matter. Yeah, actually, it will matter. A tangent of pi over 2 degrees will be some number. Yeah. Okay. A tangent of pi divided by 2, and you get nothing but an error. Okay, so you got to back up on this one and realize that a tangent pi over 2 minus u equal to a cotangent of u, and write it as a sine of pi over 2 minus u over a cosine. Whatever, any tangent of a blob, always written as sine of blob over cosine of that blob equals this. And now you're going to use your sine and cosine functions. I hope you have them memorized, formulas, sine and cosine formulas. I hope you have them memorized. Only showed them to you 2 minutes ago. So the top one is going to go sine pi over 2, cosine u minus cosine u, cosine pi over 2, cosine first, sine second. Your bottom one is going to go cosine cosine, and opposite sign in the middle, sine sine. Cotangent u. Okay. Now, individually, a sine of pi over 2 is 1. The cosine of pi over 2 is 0. Same exact argument. Pi over 2 coordinates are 0, 1. This is your cosine. This is your sine. Sine is 1. Cosine is 0 at pi over 2. So down here, 0, 1. So I wind up with a cosine u, all this dies, and I wind up with over a sine u. And a cosine u over a sine u is identical to a cotangent u. All right, but most of the time you can directly plug into a direct formula and get it to work. Unfortunately, they started with one you can't. Why don't we try a few others down the page? Why don't we try 25? Sine, verify. The sine of x minus pi over 2 is a negative cosine of x. I hope you got your formulas memorized. See, it matches cosine of first minus second. That would go sine of first, cosine of second minus, see, remember that matches, cosine of first, sine of second. All right, well, a cosine of pi over 2, remember, is 0, and a sine of pi over 2 is 1. So this is 0, it dies, and you wind up with a negative cosine of x times 1. And sure enough, that's a negative cosine of x equals negative cosine of x. So I hope you find these identities a little easier because they were built to follow these formulas. What about one like 31? Page 587. Sine of a pi over 2 minus x is identical to a sine of pi over 2 add x. All right, this is probably going to be a case of using the formulas on both sides. So you're going to go sine pi over 2, cosine second, minus cosine of pi over 2, sine second. On the other side, sine pi over 2, cosine second, add cosine pi over 2, sine second. After a while, you get it memorized, especially after you've taught it for 32 years. Okay, again, a sine of pi over 2 is 1, a cosine of pi over 2 is 0, a sine of pi over 2 is 1, and a cosine of pi over 2 is 0. So we come down with a cosine x times 1 there. That dies. We have a cosine x times 1 here. This dies, and there you are. So yeah, these have been cooked to follow the formulas. (41) is probably an example of something that looks real hard, but if you think about your formulas, and y over 1 plus, no, it's not as easy as I thought. They left the 1 minus, they left the signs both negative, top and bottom, tan x, tan y, equal to a sine of x minus y over a cosine of an x plus y. All right, this is kind of a case I can imagine myself plugging in here, turn it to this, or I probably could go either way. Looking at my crystal ball, I'm not sure which. You're gonna sine over cosine, and then you're gonna get common denominators, and bury myself. I'm gonna have to try to match the formulas. Let me try to expand over here, right side, and see if I can divide through by something creating tangents. You're gonna get a sine of x cosine of y minus cosine of x sine of y. Bottom cosine of this will go cosine cosine with an opposite sign, so still a minus. So this one matches sine x sine y. Now I want to create a tangent x. I got a sine x, which means I got to divide through, to get a tangent x, I got to divide through by cosine x, but that's not going to, and a cosine y to cancel it. Let's divide top and bottom by cosine x, cosine y. And bottom by cosine x, cosine y. Let's see if we can get it. Write it out real slow. Sine x cosine y, cosine x sine y, and divide each piece by cosine x cosine y. Cosine y. So on the bottom, same thing. Cosine y minus sine x sine y. If you divide everything by the same thing, it's legal. Cosine x, cosine y. Divide everything by the same thing, and you can see you generated a tangent x. Cosine here cancels. Sine y over cosine y is tangent y. Tangent y. Everything here cancels, leaving you your 1 minus sine x over cosine x is tangent x. Sine y over cosine y is your tangent y. And the signs happen to be the same, top and bottom. this is your equal to your left side. Okay. Let's jump on, try one like 47. We're going through 57. So let's try one like 47. Cosine of an arcsine of x and arctangent y. Write in terms of x, y only. Seven there. This to me is where it's helpful, again, to think in terms of first, second. So cosine first minus a second. Remember that one, cosine, cosine, opposite sign here, plus sine, sine. So you're going to get cosine, arcsine x, cosine, arctangent y, opposite sine of both, sine, arctangent y. Now, what I'm doing, I'm looking through this for anything that directly matches. You can number these piece 1, piece 2, piece 3, piece 4. 3, easy. Sine of arcsine x is just equal to x. Direct match, direct inverse. These are direct inverses. The only one that works like that. Okay. Other pieces have got to be, you must draw a triangle for the other pieces. Or the other pieces. Look at piece 1, a cosine of an arcsine of x over 1. Remember a sine, and again, it doesn't matter, it's arcsine, it still works by sine. Opposite hypotenuse over hypotenuse, so your x goes there, 1 goes there. And I'm speeding this up, so I hope you know that's the square root of 1 minus x squared. You would take your hypotenuse squared, subtract the leg squared to get the other leg squared. Your cosine is adjacent over hypotenuse. This will equal square root of 1 minus x squared over 1, which is equal to the square root of 1 minus x squared. So piece 1 is the square root of 1 minus x squared. Maybe I'll write it underneath here. That's the square root of 1 minus x squared. All right, piece 2. And really piece 4. Piece 2 is the cosine of arctangent y. Piece 4 is the sine of arctangent y. I can get both of them off the same triangle. You're calling that angle arctangent y. You should point out I'm calling this arcsine x. Okay. Do piece 2 first, over 1, put that over 1, and your tangent is opposite over adjacent, making this the square root of 1 plus y squared. Leg squared, add them up, take square root, you get hypotenuse. Piece 2, cosine of arctangent y is equal to 1 over the square root of 1 plus y squared. Adjacent over hypotenuse. Sine of of arctangent y to y over the square root of 1 plus y squared. This is adjacent over hypotenuse, opposite over hypotenuse. Plug in, and you get, maybe I should show it up here. I've just shown your piece 2 is 1 over the square root y squared, and I've just shown that piece 4 is y, 1 plus y squared. And I've shown piece 3 is x. That was easy. Okay, so I hope you can plug out. Yeah, this it gets complicated. It gets a little it's really not that hard, but it's tough to show in this smallest space. So plugging in piece 1, square root 1 minus x squared. Piece 2, 1 over square root 1 plus y squared. Piece 3 in x. This was piece 1, piece 2, piece 3, piece 4, y over the square root 1 plus y squared. You can clean it up a little bit. 1 minus x squared over the square root 1 plus y squared and plus xy over the square root 1 plus y squared. Now the original formula looked like this. And I've come down with this nasty formula like this. Could use the calculator, but I think I will see how close I got to the answer in the back of the book for this one. I'm going to sneeze again. 7-2, problem 47. Okay, they got a common denominator. Okay. Notice they've got the square root of 1 minus the x squared plus the xy, and it's all over the square root of 1 plus y squared, if you can see that. They've put it all over the single common denominator. So they crushed it together. So your book square root 1 minus x squared, add xy, all over square root 1 plus y squared. Like I say, it's hard to know where to quit sometimes. I should have spotted that. But I wouldn't mark this right and that wrong. You know. Well, that only took down to 3 pages. Try to explain that. Like I say, it makes perfect sense to me. Okay. Back to 7-2. Try a couple more. Seven, 2, what could we try for a few more here? Well, we really bury you in formulas in the next section. Okay, they give you some numbers in 51. And we're on to page, we're on to page 588. Take sine of an arc cosine of a half and add an arctangent of 1. Find exact value. Well, I'm sure you have it perfectly memorized that this sine, first plus second is first plus second. So it should go sine, cosine, arc cosine and a half. Cosine of the second, which is arctangent 1. And same sign in the middle plus cosine first, arc cosine of 1/2. And I hope you spot instantly that's a half. And then times, ran out of room, sine second, arctangent 1. Sorry, I couldn't get it all on one line. This is multiplied. This is a cosine of this, cosine r cosine. That would cancel, give you a half. And so it's sine first, cosine second, cosine first, which is easy, sine second. And play the same game if you want to number the pieces. 1, 2, 3 is easy. And 4. Arc cosine of a half. Try to work them the same way. If you're really good, you could know that instantly. They've used some circle values here. But I think I'll just play the same game. Piece 1. Okay, cosine would be adjacent over hypotenuse, and this would be the square root of 3, and your sine would be the square root of 3 over 2. Our cosine of a half would be square root of 3 over 2, opposite over hypotenuse. Piece 2 and piece 4. You can notice the arctangent of 1, so that means you're getting 1, 1, and this would be the square root of 2. So cosine is equal to 1 over root 2, which is going to be root 2 over 2. See, these are circle values. Piece 2 and piece 4. Your sine is the same thing. 1 over square root of 2, sine equals 1 over, which is equal to square root of 2 over 2. So plugging in, piece 1 is root 3 over 2. Piece 2 is root 2 over 2. Piece 1, piece 2. Piece 3 is a half. Piece 4 is also root 2 over 2. And you're winding up with root 6, add root 2, and it's all over 4. I'll look that up, 7.2, just to double check it. 0.251. Yeah, they factor out the 1/4, but put a 1/4 in front and then have root 6 add root 2. Okay, then you go to 55 and they really are messing with the letters. So I hope you can figure out this gibberish. Page 588. Fine. All right, cosine, and this is a theta minus phi. If you've ever gone to a fraternity over at UG or whatever, that's a theta and that's a phi. You see these symbols used in theta in fraternity names. Okay, it's hard to, they don't really number these conditions. I saw number 1. Okay, cosine of theta is 3/5, and your theta in quadrant 4. Puzzle this out. A tangent phi, we'll call it number 2. Your tangent phi is negative root 3, and phi's in quadrant 2. All right, I hope you can puzzle this out. Once again, it's plug and chug. This is first, this is second. I'm going to write out what we've got to plug and chug into. So cosine minus phi, remember when? Cosine, cosine, add sine, sine. Once again, we can number piece 1, piece 2, piece 3, piece 4, if it helps you keep track of them. All right. Well, piece 1 is easy. It's 3/5. But the rest of them are not going to be near as easy. We got to puzzle out the rest of them. But I always look over the whole thing for easy ones. And so a cosine theta is 3/5, 3/5.
Plug and chug right in. But now we got to draw triangles for the rest of it. Why don't we go for piece 3 next, because it's also on theta in your quadrant 4. So piece 3, quadrant 4. Now your cosine theta is 3/5. That's going to be adjacent over hypotenuse. Can you tell this is going to be this square, 25 minus 9 is 16. Oh yeah, 3, 4, 5, right triangle, but it's going to be negative 4. That's theta. So your sine of theta is going to be a negative 4/5. Negative 4/5. Piece 3. Okay. Now we got to go to this phi triangle, and we can do piece 2 and piece 4 right off of it. Piece 2 and 4. Phi's in quadrant 2. Phi. Do it that way, but it's okay. Tangent phi. All right, remember it's tangent's y over x. So that is gonna, your y is positive, so that's gonna put your √3 here, and your x is -1. So your tangent is y over x negative √3. And your hypotenuse, that's gonna be a 3 squared, add 1 squared is 4. It's gonna be even 2. This squared is 3, negative 1 squared is 1, 3 plus 1 is 4, square root of 4 is 2. Cosine phi will be -1/2, adjacent over hypotenuse. Sine phi will be positive √3 over 2, opposite over hypotenuse. Plug those in, -1/2. Adding here, in piece 4, it's √3 over 2. Therefore, you're going to get -3/10, -4 √3 over 10. Book probably crushes it together. -3 minus 4 √3 all over 10. 55, 7/55. Yeah, they pull out a -1/10, but you got your 3 plus 4 √3. Pull out 55. There you are. 3 plus 4 √3, but they pull a -1/10 to the front. -1/10, pull out the negative out, pull the 10 out, 3, add 4 √3. All right, we said to stop at 57, so we'll have plenty of problems left for Friday's video. We'll go ahead and, this has probably gotten long enough. Sorry that it got a little choppy. Had a few interruptions, but we'll do one more video on this, work more problems on Friday. I will end the meeting. Thank you.